vectors. Now vectors are just like arrays. The only real difference is that their size can change. And how you create a vector is type in vector and then the data type you want to store. And then let's say that I want to store lottery numbers in my vector. I'm going to decide that the initial size should be 10. I could then create an array to show you how to put an array in a vector. And let's say it has a size of 5. And then we'll initialize it just like we did before. 14, 24, and 34, like that. We can then go and take our vector and insert our array. And how we're going to do that is go lottery number vect and say that we want to start inserting at the beginning of our vector. And then we'll say the array that we want to insert into it. And then let's say that we only want to take the first 3 numbers from our array, right, like that. We could then go cout and just print lottery num vect like that and at, and let's say we want what's the third item, which would be second index, whoops, like this. We want to output that on the screen because remember it didn't take the whole array, just took these first 3 numbers. And there you can see 14 popped up. Now if you would want to also come in here and let's say we want to add another value into the 5th index, lottery num vect dot insert. We could then go lottery num vect dot begin, which is the beginning of the vector, plus 5 to get to the 5th index, and then put 44 inside of there. We could then jump down here to 5 and see the 44 popped up. Pushback is going to add a value at the end of our vector. So pushback, and let's say we want to put 64 in there. We then wanted to find, as you can see, the vector resizes. We then wanted to find that final value. We could call back and it would get it for us. As you can see right there, pop back is going to remove the final value. Well, there's no point in doing that, which in this situation would be 64. And then we could get the first value in the vector by calling front instead of back. We could get the last element by calling back, of course. Empty is going to return 0 if the vector is not empty, and a 1 or true whenever it is empty. And then finally, if we wanted to get the size of our vector, we can do that with size. So there's a rundown of all we can do with vectors. Now let's take a look at what we can do with functions inside of C++. Now your functions are actually going to appear before your main function, and it basically just has the return type. So let's say that we wanted to have a function that added numbers. We would have our return type for our function. If it didn't have a return type, it would have void instead of integer. And then we're going to define the data types for our attributes that are going to be received by our function, second num. We could also set it up so that this function would have a default value, which means actually you wouldn't have to send a second attribute in that situation. The only thing that you have to do is, if you do this, is all of your functions that have a default value or all of your attributes that have a default value have to come last. So this has to come before that. So that's the only rule there. And this is also known as a function prototype. We could then go and type in combined value is equal to first num plus second num, store that in there, and then return the combined value. And I did it this way so that I could demonstrate something else. You could take this right here and put it right down here in the return part right there. You don't have to create a new variable just to perform that. Another thing I want to demonstrate, since I'm up here and not inside of main, is that you are able to overload functions, which basically means you can use exactly the same name but different attributes. So I could come in here, even though I have add numbers already. Actually, let's just copy the whole thing, paste it in there. So there's add numbers twice. It's okay to have add numbers. The only problem is we have to have different attributes inside of here. So let's say we have second num, and we also have another integer, which is going to be third num. And like I said before, we don't need all that. We could just go return and perform our addition right inside of here. Second num, third num, and return that. Now let's jump down inside of main and actually call these functions. If I didn't mention before, functions basically allow you to reuse code and also add a certain level of organization to your code. So here, add nums, I'm passing in 1. I'm going to use the default value of 0 there. Not going to pass anything in, just to demonstrate it. And then I'll show the other one as well. Add numbers, 1, 5, and 6. Endel. And you can see if I execute that right there, you got 1 and 12 pop back on the screen. Let's go and create a little bit more complicated function here. And this is basically what they call a recursive function. And this is normally demonstrated using the getting of factorial. So that's what I'll do. Get factorial, int, number. and this is going to be a function that calls itself from inside of itself. Sounds way more complicated than it is. So I'm going to go and create an integer called sum. Then I'm going to say if number, which is going to be passed inside of here, is equal to 1, then I want to have sum equal to 1, else sum is going to be equal to get factorial, see, calling itself from inside of itself. And here I'm going to go number minus 1 times number. And this is going to get our factorial, because here we're then going to return sum. So very quick way to get the factorial of a number. And basically what is going on here is right here, we'll come down to this part. This is the first time through this function. And let's say number is equal to 3. Well, in that situation, get factorial is called with the value of 3. Well, it'd actually be 2. Let's just focus in on this one right here. So 3 minus 1 is equal to 2. In that situation, it's going to return a value of 2. And then we're going to multiply that times 3. So right here, whenever we're going through here the second time, this time we're going to be passing 2 into the get factorial. So there we are. And 2 minus 1 is going to be equal to 1. And in this situation, this is going to return the value of 1. And get factorial in this situation, whenever it comes in here the third time, number is going to be equal to 1, so sum is going to be equal to 1. And that's going to end that function's execution. And it's going to sort of ricochet back up to the beginning. So what we're going to be left with in this situation is this is going to return 1, which is going to be multiplied times 2. That 2 right here actually goes right here, and then we'll multiply that 2 times 3, which is going to give us our final value of 6. And let's go through here and let's actually run it to make sure that that's what it does. And how to find out is to go factorial of 3 is, and then call the function. Get factorial, pass in the value of 3, and L. Make sure I come up here and have the return value be an integer right there. And then also come in here and remove this little parentheses I put in there by accident. And if we execute it, you can see factorial of 3 is 6, exactly like we demonstrated up here. So there's a rundown of functions inside of C++. Now I want to cover file I/O, or how to read and write files using either text or machine readable binary. So I'm going to create a string here. And I'm going to call this Steve quote is equal to, and I'm going to say a day without sunshine is like, you know, night. Now what I'm going to have to do is create an output file stream to create this file if it doesn't exist, or what it will do is create a function or create a file if it doesn't exist. And I'm going to call it writer, and I'm going to define the name that I want to save this text into, and I'm going to call it stevequote.text. I'm then going to verify that the file stream was created so that I'll be able to write to the file. If not, I'm going to put out an error message. And then if we want to signal that an error has occurred, we can return a -1 in this situation. Else, if the file stream is open, that means we can write to the file. And it's very simple to write text to the file. Just go writer and the string you want to write. And then I'll throw a new line on there at the end. And then very importantly, you also want to come in and close that file stream at the end. And I'm going to continue going here because we got to read from it. Let's say that you also wanted to come in here. Our file stream's closed, so we're going to create another one. And I'll just call this writer2. And then in this situation, what we're going to do is we're going to define that we want to write to the Steve quote text file. And then here we're going to say that we want to append what we're going to do next to the end of what's already there. Now there's a whole bunch of different symbols we can use here to do different things with files. Like I just said, with iOS app, we're going to be able to append to the end of the file. With iOS binary, we're going to be able to treat the file as if it's binary. iOS in is going to open a file to read input, which you're going to see here in a minute. iOS trunc is the default, what happens whenever you don't use one of these symbols. And then iOS out is going to open a file to write output. But in this situation, we're going to be appending. And once again, we're going to need to come in here and check that this file stream is already open. And I'm just going to copy this, paste that in there. Oh, make sure this is writer up here instead of write. There you go. And this is going to be writer2. We're going to spit out an error again if the file stream was not opened. And then to append in this situation, we're going to go writer. And then let's say that we want to put on a new line, \n, and then a dash, and then type in Steve Martin. We then could come in and say writer close, and there that is. Alright, so we wrote and we appended and we created the file and did all that. Now I'm going to create a character that's going to hold each of the individual characters we're going to read from our file, and we're going to read these characters using an input file stream. So input file stream, and I'm going to call this reader, and you need to tell it exactly what file you're going to be reading from. And then I'm going to check if that stream is going to be open, just like we did before. Put the reader inside of there, come in here and print error again, return error code -1. Else, we know that we got our stream open and we'll be able to read from that file. And we're going to use a for loop in this situation to read each character from the stream until we get to the end of the line. So I'm going to go int I is equal to 0. Then I'm going to go while the reader does not get to the end of the file, we're going to continue reading characters, and then we'll call reader get to get the next letter of output that we want. And then in this situation, let's just say that we want to print that out to the screen, type in letter. Then after the for loop's all done with, you go cout and del, and then once again close the reader. If we did that all right, day without sunshine is like, night. So you can see it worked out, and those are all the different things you can do in regards to reading and writing data using C++. I'm going to briefly touch on exception handling, and exception handling basically allows you to avoid potential problems. In this situation, I'm just going to focus on one, which is a division by 0 error that could cause all kinds of problems. Now, whenever you want to cover something that could cause an exception or an error that you want to be able to catch, you're going to surround the code that could potentially cause that error inside of what's called a try block. And then what we're going to do is we're going to have an if statement inside of here that says if the number is not equal to 0. Well, in that situation, we can say cout and divide by number, like we have there. But as we can see, that is going to cause an error, and we're never going to get there. Else, we're going to say throw number. Now, this throw is going to look for a catch. And the catch area is where we are going to catch the number that was entered. You don't have to do this, but it helps so that we have the error message make sense. And then we could do something like number is not valid, and then maybe have them ask them for it again. You can see here if we run, 0 is not valid. So instead of causing an error right here by putting this inside of a try block and then throwing if they would actually enter a 0, which causes potential errors, we're instead going to catch it down in this area right here and solve it and keep our program from crashing. So that's a brief explanation of exceptions. Okay, now let's talk about pointers. Now, when data is stored, it is stored in an appropriately sized box that is based off of its data type, just like we covered previously. Here we have an integer, and here we have a character. Now, like we did before, we're going to be able to come in here and use size of to determine how many bytes that data is going to take up. And we can see here, whenever we run the program, that the integer is going to take up 4 bytes, and the character is going to take up 1 byte. Now, you're going to be able to reference this box, or this memory address, where all of your data is stored, with what is called the reference operator, which is an ampersand. So we could come in here and go cout, and my age is located at, and then use the reference operator followed by my age. And when we execute that, you can see the memory address right here. Now, what's really cool about this is whenever we don't use pointers or we don't use reference operators and we change a value of a variable in a regular old function, that change of value does not carry on. It is lost. And the reason why is whenever we use regular functions, what we are in essence doing is passing a value into that function. So even if we had, let's